Alright, so here we have this question, invert binary tree. So it's like visible right here what has to be done. Left and right will be getting swapped. So this is getting exchanged with this is gonna get exchanged with this, and this is gonna get exchanged with this. We're gonna try two approaches. First will be depth first search, which is pretty simple. Second will be breadth first search. I wasn't able to recall the question, so I was like, let's do it again. I was forgetting it again and again, so yeah. This is yeah. Let's start the question. So, what can be the thought process about this question is the place where I was getting confused was that when we're talking about inverting, you know, swapping left and right, I was more like we're doing it at a particular level. So maybe it's about breadth first search and everything, but yeah, I mean, we'll see about that. But let's see how the depth first search works first. So basic thought process is to swap the children and then to swap the parent. That's it. Nothing else. So for example, if I create a helper function, I put in the node in it, I take in a node, and then what do I say? I'll have a base case wherein I'm like, if node is gonna be null, I'm gonna say that it's fine. You return null. Yeah. And then I'm gonna say that, alright, now suppose if my node hits null, I'll be like, let's return null. I'll need to store values. Yeah, I'll need to store values. I'll say, tree node left, and then I'll say tree node right. Yeah. So what's this gonna do is, so this will be like, I'll be storing left and right nodes, right? I'll be like, it's gonna call helper with node dot left, it's gonna go into the left. This is gonna call helper, this is gonna go into node dot right. Yeah, I'll be having a left and I'll be having a right. And what I'll do then, I'll say that it's fine, I'll have a left, I'll have a right. Now I'm gonna say that my node dot left can be my right, and my node dot left can be right can be left. Fine. I'll say return node works. So what's gonna happen is, let's have a draw run for it. It's gonna bottom down, it's gonna come below. For one, it's gonna check left, it's gonna be null, it's gonna return null. For right, it's gonna be null, it's gonna return null. So now one is having its left and right as null. So yeah, the thing is gonna work. It's gonna swap null, it's not gonna matter. It's gonna return the node, that is 1. It's gonna go up to 2. Same thing's gonna happen for 3, it's gonna go up to 2. Now 2 is having left as 1 and 3 as its right. Then it's gonna swap, then it's gonna return 2, and then yeah. So I'll call helper, passing root into it, and that's it. Yeah, let's see. My bad. Cool, works. So now let's try the breadth first search solution. Alright, let's try that. We'll comment this out. Yep. Now we'll try the breadth first search solution. So what would that be like? Yeah, what's my breadth first search gonna look like? In my breadth first search, I'll be talking about, you know, the particular node at each level. When we know it's breadth first search, we know it's gonna be at a level. We know it's gonna include a queue. So I'll be creating a function because I will have to, like, for example, like let's do it. Let's do it. Then I'll tell hand by hand. I'll have a tree node kind of function wherein I will have a node with me, and then I'll say, cool, if it's null, this is basic, I'll be returning, why did I write returning? I'll be returning null. And then what do I do is, now I'm like, alright, let's have a queue. Let's create a queue of tree node type. I'll call it a queue, and then it's gonna be new linked list. Yeah. Now I have a queue. It's new linked list. Now the thing is that what do I do is I say into the queue, let's put the root node into it. I'm like, let's put the root node into it. So I'll be like queue dot offer. I'll put the node into it, whatever I'm having. Yeah. Then I'll say that till the time the queue is not empty. Yeah, till the time it's not empty, do one thing. Create a new node that is going to store the one that I'm gonna use current as the name. Now what this is gonna do is I'm gonna say queue.pop. Now this pop is gonna remove the node from the front of the queue, so that is how it's gonna follow first in first out. It's gonna remove the node from the front of the queue but also return its value. So I'll have to store it somewhere, so I'll be storing it in current. So I'm like, I stored its value into current. Now I'm gonna say that, cool, now I have this 4 with me in terms of current. Yeah. Now I'll say tree node temp equals current dot left. Then I'm gonna say current dot left equals current dot right, and then I'm gonna say current dot right equals temp. Yeah. So basically what I did was I swapped the elements. I swapped the elements, or I would say the children of current. That was my initial node that I had. Yeah. Now what I'm gonna do is I'm gonna say, alright, the swap took place. Yeah. The swap took place. It's fine. Now I'll be adding into the queue as well. Yeah. But I cannot add a null value into the queue because it's not gonna make any sense. Yeah. So I'm gonna say that if my value is not null, so the things that are happening at the moment are, I'm having a node, I'm having its children, I'm swapping them, and then I'm gonna say that, alright, I swapped the children. Now I'm gonna add the children into the queue. So then I'm gonna say that if current dot left is not null, if that's not null, then queue dot offer Because the thing is that the moment I add null to it, what's gonna happen is it's gonna pop it. It's gonna store current equals to null then, and then current dot left, that is null dot left, would be giving an error. I can't do something like null dot next. So I'm gonna say if the current dot left is not null, then q dot offer current dot left. I'm gonna copy paste the same thing. Yeah, but here it's gonna be for right. Yep, it's gonna be for right. Then after the while loop is done, I'm gonna return the node. I guess that's it. I guess I can put this into the same place, like right here. I don't need this thing. Wait, what's the issue? I mean, I'm removing the element, so wait, that doesn't make any sense. Wait a second, what's the issue? Current equals q dot pop. Oh, my bad, my bad. It's poll. Yeah. Apologies. Yep. So yeah, that was the approach. There was no need for a separate function. All that had to be done was at the root, swap its. I added the root to the queue, and then I had a while loop. I stored the popped element, that was the first and the root element. Then I was like, store that into current dot left and right. I swapped them, I added them, and that's it. I added the children, and yeah, I returned root. Cool. So I guess this was inverting a binary tree using both depth first search and breadth first search. So yeah.